are drums. And this is a drummer.
While not technically people, drummers do play an important role in the modern music ensemble. Therefore, sound engineers go through all the trouble of setting up microphones all over their drum kits. This is a set of microphones that we make specifically for the drum set. They come in a nice suitcase, they clip directly onto the drums themselves, and of course, they sound amazing. When everything is all mic'd up, the drums sound like this. Consider this one microphone for a second. In that last clip of audio, this channel was only needed for those last tom hits right at the end. The rest of the time it was just picking up all the other microphones around it and sounding like a poorly positioned microphone for any of the other drums. Here's what this channel sounds like by itself from that last clip. To solve this, sound engineers often use a gate or an expander. The gate says that when the incoming sound is below a threshold, turn it off. However, some drummers are capable of playing a tom quietly, but still play the snare loud. That means that when the engineer sets the threshold low to let the quiet tom hits through, the snare will open the tom gate. Here's what the gated tom channel sounds like. Notice how the gate still opens for a lot of the snare hits. There are some clever tricks to improve this using a bandpass sidechain, but that really only offers a marginal improvement. But we had a better idea. We put lasers on it. Instead of trying to figure out which drum was hit using the microphone close to the drum, we directly measure the physical vibration of the drum head itself. By reflecting a laser off the surface, we can measure if the head is vibrating or not without affecting the drum's natural acoustics. Now, when we plug the detector into the sidechain or key input of the gate only opens when the drum is physically hit, and not just when there's a lot of noise around the microphone. Here's that same tom track, but gated with our laser system. This little prototype box was made to sit on top of our existing drum clip. So now, if we look at the front of the gate, we can see how well this whole thing works. This is the kick channel, and the snare channel, and the rack tom, and the floor tom. Now, pay attention because this is the part where it gets tricky. When this light is red, it means that the gate is closed. When the gate opens, this light turns green. Because this is a video, feel free to pause and rewind to review that last section if you need to hear it again. Right now, the key input is off, meaning that the gate is opening in normal, non-laser mode, triggering based on the signal coming from the microphone alone. Notice how a single drum hit opens multiple channels. When we turn on our fancy space-age laser system, hitting the individual drums now only opens the correct gate channel like you would expect. Sennheiser already makes specialized microphones designed for a specific purpose, like this set of drum microphones. By paying attention to how these microphones are used, we can design context-specific microphone systems that work smarter to enable additional functionality while still delivering the sound quality that we've built our reputation on. And most importantly, we did it with lasers. While this system was designed for drums, everything that makes sound vibrates, so it's easy to imagine how similar systems could be developed for other instruments or other applications, like smart feedback control or other types of dynamics processing. If you have any questions about this system, comments about potential applications, or you want me to go over that whole red light, green light thing again, send me an email at andrew.greenwood@sennheiser.com. Happy drumming!